Okay, here, using the Ka values provided above. Is it this one? Let me check. Yeah. Okay. Suggest a K value for 2-bromophenol. Explain your answer. Okay. So you go back to the table here. Now, 2-bromophenol, you can compare between these two, right? If you compare phenol with 2-bromophenol, which is more acidic? 2-bromophenol means you just have extra Br, right? So which is more acidic? You go back to you draw the conjugate base again, then you look what's the difference. The difference is the Br. So the nature of the Br is, Rashida, you help me out. The nature of the BR is, because you say you don't know how to answer this sort of question, right? So now I'm leading you through, okay? So you draw this out. Self-declare break again, my dear. Okay. Phenol. Alright, after you remove the H, it gives you phenoxide, right? 2-bromophenol means the Br is at the second position relative to the OH, right? So you compare these two, right? Your thought process, compare, draw out the conjugate base first, okay? Compare meaning you look at the difference. That's meaning a compare, right? I have an extra Br. You tell me what is the nature of this Br? Withdrawing or donating? This is a content you need to know, right? A concept you need to know, right? Yeah. Remember that time we did a table where we compare the difference. Yeah, good. Remember we did a table, a comparison. Can I have the nature of BR? Anyone can help me out here?
Electron.
Okay, because it's electronegative. So also all these things must know, right? So which means that which lone pair on the O delocalize more? Which one delocalize more, Lashita? This or this? This is E, electron withdrawing, because electronegative. It pull. So which lone pair delocalize more? These are the A rings. This one pull. So you have the extra pulling effect, right? So which lone pair delocalize into the ring more? This one. Right? So which is huh?
Wait, cannot go there.
It's like a chain effect like that. So this pull, then this also pull in. That's all. Okay. So therefore, this is more stable compared to phenoxide, right? So in terms of the original acid, your 2-bromophenol definitely has a higher Ka, right? So if I have this, okay, the K of this one here will be bigger than that of your phenol, right? Am I right to say that? Okay, now next. Okay, then you look at the table here. You realize that actually we can even give a more specific answer, okay, by comparing your 2-bromophenol with 2-chlorophenol. Then the only difference is, instead of the Br, we have the Cl. Now, make sure you help me out here. So the only difference is these two, right? So what can you tell me?
Cl pulls more, so
very good. Why Cl pull more?
More electronegative.
Very good. Cl is more electronegative than Br. How come we know that? Which chapter does this?
Is it the downward group?
Atomic structure. Yeah. Okay, so Cl is more electronegative, right? Which means that the lone pair on this one delocalize more. Okay, so which means that the Ka of 2-chlorophenol should be the highest compared to the other. So something like that. Okay, so see how the question say. Suggest a K value, right? So you can state any value as long as it's between this and this, between 1.3 and 9.6 times to the power minus 10. Will do. Okay, understand? All right. Okay, I'll show the answer now. But as I show the answer, I will explain one more time, okay, to John as well.
But they may not do it.
I don't remember doing part C. I think we did A and B, right? Or we did part C. We didn't, right? We did part A and part B. So this is C, so I explain to you again, okay? And the rest, you can take opportunity to listen to me one more time again, okay? So like what I mentioned, right, over here, we always compare the conjugate base itself. So first thing first, we compare 2-bromo, okay, this one here to this. We realize that Whenever we compare, we look out for the difference. So the difference between these and these is the presence of Br. Br is electronegative, which makes it electron withdrawing. So this lone pair on the O minus delocalized more. Next one. Compare this, right, with your coral here. Okay. So again, the only difference is the Cl versus Br. Cl is more electronegative. So therefore, the lone pair of this O minus delocalized in the ring to the greatest extent as compared to the other two. That's all. Okay. Yeah.